we also wanted to share with you the link to the Developer Edition. You can go ahead and download that now. You'll get an email with instructions to install via Docker or VirtualBox. And with that, I think we'll go ahead and introduce our speakers today. So I'm going to introduce Emma, and she'll introduce Huiting. So Emma Liu is our product manager.
Hi everyone, my name is Emma Liu. I'm a product manager at TigerGraph. Previously I worked at Oracle as a software engineer and at MarkLogic as a product manager. And my focus at TigerGraph is on cloud, containers, and enterprise infrastructure and monitoring, as well as the managerial aspect and the connector infrastructure. Joining me today is Huiting Su. She is a software engineer from our solution engineering team. Huiting has a master in industrial engineering from Purdue, and she has a focus on graph algorithm, as well as the analytics, big data analytics, and machine learning. Huiting has helped many customers to build solutions using our GSQL language, and she is our resident GSQL expert. In today's webinar, Huiting will show us a demo on the time dimension data analysis. I want to start with a few numbers. 3.5 billion. Let's look at a few, that's the predicted number of cellular IoT connection by 2023. 200 billion. That's the number of tweets the world sends out per year. And we are looking at this information. What can TigerGraph help you? Before starting, there are three main categories that we're positioned to help you. And these solution sheets will help you understand how TigerGraph can facilitate your digital transformation. This is the new 14 solution pages we're putting out. Our foremost design philosophy is to help resolve our customers' pain points and help drive better business outcome. And do you want to increase your top line and bottom line? Have you thought about how to reduce your costs and manage risks in your business operation? And also improve the operational efficiency. Many of the Fortune 500 companies have achieved dramatic business outcome from the real-time temporal data analysis. The ROI for these companies using TigerGraph has been tremendous. Before starting talking about a specific use case, this is a great news that we've created the 14 new use case solutions for our customers. And the main categories, there are a few customers that we are looking at, Wish.com and China Mobile and Visa. And all of these companies have been using TigerGraph and help them to improve their operational efficiency and reducing costs. And those use cases are around recommendation engine, fraud detection, and as well as IT and network resource optimization. Our webinar today is actually related to temporal dimension analysis. And how does that help your business to improve operational efficiency with recommendation and trend analysis? So here is the URL for the updated solution resources. And the time series analysis link is also here. Today's agenda, I want to start with what is temporal data analysis. Then we're going to go into a few real-world use cases and why TigerGraph is a very good fit for the temporal data analysis. And Huiting is going to help us walk through the TigerGraph solution for the temporal data analysis. And she will go into the design and how she implemented, and as well as the demo. What do we mean by temporal analysis? We always say that timing is everything. Not only that, timing also exists everywhere. you go. Today's big data world really gathers continuous data across time. For many of the problems we're facing in our life, we are reaching an understanding of the present situation and predict future scenarios from investigating and analyzing the past data and patterns. And past, present, future are all related to time dimension data. Temporal data analysis are looking at the data across time, and we're thinking about the changes, trends, and evolution in your information system. We are looking at correlations as well as some of the potential causality discovery from the sequence of graphs. With time dimension, your insights are deeper and actionable. Here, I want to address the difference between just a pure strict time series analysis and temporal analysis. In high level, temporal data is a bigger concept than time series analysis. Time series analysis in a strict sense means monitoring a metric which has two dimensions, the time and the metric. And a typical query may take a time frame parameter and a time interval parameter, then use a built-in function or UDF to calculate the statistics of the metric based on these two input parameters. And temporal analysis here we're taught is a larger concept than just the pure time series analysis. It means analyzing the data set with time together with many other dimensions. And this is a much richer queries, which requires a performant database engine. There are many use cases around us. We can extend the temporal analysis in many industry verticals. And applications deal with such data is those financial transactions with associated timestamps, inventories that continually change over time, as well as processes which involves machine logs and events coming in, say, 24 hours and 7 days a week. We can being able to analyze the data across a particular period of time, whether it's volume or size of the payment transactions and the cost of care for a specific health condition, or machine logs or security events. This is very useful for multiple verticals across banking, insurance, healthcare, government, telecom, and other industries. You probably have heard of Internet of Things, which are more related to the physical objects. I want to extend the concept of to Internet of Everything, IoE. And this everything is about objects, people, and also virtual concepts in your network. With the timestamp on all entities in the graph, what are some of the common high-level information people can explore? First and foremost, what are the objects and network states at a specific time? Looking at the graphs here, graph at T1 is the initial state that question 1 is exploring. And question 2 are really asking, how does T1 graph evolve and change to T2 graph and T3 graph? Here, I also want to bring up a concept of a 3D and 4D graph. When you have time dimension, your graph becomes a 3D graph. And when you add the geo dimension, it is a 4D graph. And you can consider adding more dimensions to become even more multi-dimension graphs. A common objective for IoE temporal analysis is to develop a model to predict the future. For example, using the time dimension analysis and correlation in your information to analyze and predict stock price. Another use case, in Graph Guru 8 about Geospatial, we covered our customer use case on real-time taxi positioning. This is actually both a temporal and geospatial real-world customer problem. In this case, Internet of Everything is taxi and people. And you can listen to this webinar from the link below and get the detailed information about this use case. But the basic scenario is, it is 11:15 p.m. on Saturday night in Ginza. A big baseball game finishes and many passengers around Ginza area. How do we predict the taxi needs for Saturday at 11:15 p.m. Japan Standard Time? Our customers provide us with historical traffic information, and from that, we can predict from the real-time and historical information with timestamp, we can predict the taxi needs at a future date. And we can come up with recommendation actions. And how do we approach this problem? In the geospatial webinar, we talked in detail how we split into the information into geogrids, and we're analyzing the historical information and real-time taxi supply to predict demand. With TigerGraph, this type of complex real-time decisions are provided to the ride-hailing platform with both temporal and geospatial analysis. Another insights from the same set of data for this Japanese customer. Imagine our customer, Yushi-san, lives in a suburb neighborhood. He comes Friday night to the electronic market, and Saturday night he goes shopping at Ginza and then goes to a restaurant. And Sunday night afternoon, Yushi-san takes his kids to Tokyo Zoo. Those are the information that the ride-hailing customer can collect from with timestamp information. And we are able to use the historical information and the real-time information to drive business planning and to manage the traffic flow and to provide the smart mobile recommendation for a given customer. And to approach this, we are used the geotemporal patterns for the recommendation. A few common IoE temporal analysis questions. We mentioned what are the objects or network states at time t, and what are the change over time. And in some other cases, you can predict peak workload in a server A affected by app B during certain given time range. So for these type of complex questions with relational database or a key value NoSQL database, there's many challenges. While RDBMS can do simple time series analysis with metrics and time dimension, it cannot work nicely with other dimensions. And it cannot correlate with information with complex hierarchy. And TigerGraph is really naturally fit for these type of questions because the IoE network with temporal data is naturally on a graph. And it is designed for correlating the time periods and finding the conditional temporal segmentation through the information hierarchy. And the GSQL can naturally and efficiently solve these type of complex query with time dimension. Why TigerGraph for temporal data analysis? Some of the unique TigerGraph features really help our customers to resolve time dimension analysis. You can have a deeper temporal insights to enrich your graph applications and providing these insights in real time. When you're looking at, you can come up with a real-time operational map with to accommodate the analytics with high throughput updates. And our TigerGraph engine can do deep link analytics in physical world. And these multi-hop entity relationship are time stamped. The key differentiation is with TigerGraph, You can do very complex conditional aggregation while traversing the information hierarchy. I want to quickly go over Huiting's use case. In Huiting's use case, we are looking at the social network temporal insights. The dataset has a Twitter-like information hierarchy, as you can see on the right. Huiting will go into the schema in detail later. And when we are looking at this use case, we're looking at the changes and trends and evolution in the Twitter information. And we can also do multi-hop correlation across time. And we are looking at the sequences of the graph. You can possibly do some causality with these social network information with some of the patterns. Without further ado, I'm going to hand it over to Huiting to talk about the use case in depth. All right.
Okay, thanks, Emma. I'm going to share my screen and introduce our use case. Please let me know if you can see my screen. This use case is from the LDBC, which is the Linked Data Benchmark Console. They have 3 types of benchmarks, and this is from the social network benchmark. They provide schema, dataset, and also a list of description of queries. This schema is a Twitter-like schema. It includes entities such as persons, messages, and places. A person may create, like, or reply to messages with a timestamp on the activities. Each person has a home country, and each message also has a location. Messages also have hashtags, which are specific topics they are talking about. In our demo, there are more than 3 million vertices and 34 million edges in the dataset. This demo shows a simple example to deal with time, but you can also add time hierarchy into the schema. For example, a layer of year vertices linked to a layer of month vertices, linked to a layer of day vertices, and so on. This is how the schema looks like in TigerGraph. I'm going to show 4 queries to give you an idea what we can do with TigerGraph. In temporal analysis, we often have 2 dimensions, timestamp and metric. Given a time window and sample interval, we can calculate statistics on the metric. The first query simply calculates a summary of the messages in a given time range. It groups them in 3 levels, month, comment or post, and the length of their content. Based on the content length, we can split them into short, one-liner, tweet, and long messages. For each group, it calculates the total message count, average message length, and sum of all message length. Let's go to the Graph Studio and go to the post summary query. Enter a start date and end date. Run the query. Then here is the summary. For example, in January, for a tweet length post, the message count is 287, and the average message length is 105. We visualize this using a stacked bar chart. The x-axis is the month. Post is on the left, and comment is on the right. The different length group is stacked vertically. So you can see the orange ones are short posts, and the blue ones are the short comments. This chart only shows the message count. We can see that the short messages are much more than the others, and there is a clearly increasing trend. The second query is called tag evolution. We want to see which topics suddenly become popular or not popular. This query finds the tags that were used in messages during the given month of the given year, and the tags that were used during the next month. For both months, compute the count of messages for each tag, and show the tags with the largest difference of count in month 1 and month 2. Okay. Let's go to the tag evolution. Put a year and a month. Show the top 10 result. So this is synthetic data. It may not make sense here, but for real data, we can find that people may suddenly start to talk about a specific topic, like a celebrity's death or release from prison. We use a bar chart to show the difference. So these topics are not as popular as before, and those blue topics are suddenly become popular. The previous two queries at most use one-hop graph traversal. However, with TigerGraph, we can do multi-hop traversal to consider the rich relationship of every relevant dimensions when doing the analysis on temporal data. The following queries will show how this works. The third query is holiday destinations. For the residents in a given country, we want to ask which are the popular continents to visit in each month. From the given home country, we traverse to the cities in the country, then find the people living in these cities, then traverse to and count the messages created by these people, which are not located in that home country. So there are 4 hops in total. Go to the holiday destinations and say for the United States. A lot of people travel to Europe in January. In the visualization, we use a string chart to show the seasonal trend. The width of each string here is the number of messages. We can clearly see that Asia and Europe are very popular destinations. There is also a seasonal trend that more people are traveling in May and June, which makes sense. The last one is about messages by topic and continent. Given a tag class, find all the tags in that class. For example, president is a tag class and Trump is a tag in that class. Traverse to the messages with those tags and count the number of likes they got. Then traverse to the continent through the country to get the continent which the message is located in. At last, traverse back to the messages and count the number of messages for each continent in each year and month. So there are 6 hops in total. Let's go to the message topic continent. Say for the president tag class, we show the top 100 result. So here we can see, for example, in February 2010, there are 10 messages about president in Asia. Here. And they got 234 likes in total. We visualize it with line chart and bar chart on GeoMap. The bars are message count and the lines are like count. The trend looks similar for these continents except Oceania. So I've shown 4 queries for temporal data in TigerGraph. TigerGraph allows both high-performance multi-hops queries to gather information from rich relationships and real-time update. So it can be an efficient tool for temporal analysis. Hope you enjoyed the demo, and let me hand back to Emma.
All right, thank you, Huijing. The demo is really impressive. I heard that this is the developer only used a very short time to develop the visualization, correct?
Yes.
All right. Yeah, so it's actually really easy to develop visualization.
Sure.
Yeah. Let me share my screen again and go back to slide. Let me do a quick summary of our webinar today. TigerGraph is really designed from ground up to provide insights on data with multiple dimensions. And today we focus on primarily on the temporal dimension. And one of the key advantage of TigerGraph is we provide the conditional aggregation while traversing through very complex information hierarchy. And only with our MPP architecture, you can have a performant response from these type of complex query. And Hui Ting did a temporal data analysis use case, and she showed the temporal demo, and it was very impressive. All right. Any questions? Now the question and answer. Okay. I think I see a few questions here. So the first question, how do you model time dimension in TigerGraph? And should time dimension become a vertex type or become an attributes or both? Any performance consideration?
Yeah, as I mentioned, we can further check the schema by adding the time hierarchy. For example, if a comment is created on January 15th, 2019, then the comment vertex can be linked to a day vertex called 15th, which is linked to a month vertex called January, then linked to a year vertex called 2019. So in this way, when you want to find the comments created in a given time range, you just need to traverse from the year vertex all the way to the comments, which is more efficient here in this case. Yeah.
Okay, that's cool. Let's see. A second question, how does it compare to key value database? Why is this Twitter data set especially good with TigerGraph rather than key value database? Okay, I'm going to address this question. As I mentioned earlier, with traditional RDBMS or the key value database, you are looking at a time series analysis only with the metrics and time. You cannot really do complex query and rich query with other dimensions. And if you have information hierarchy in your system, for example, in this Twitter-like data set, there's different groups, different types of messages and tags. If you want to traverse into those information hierarchy, you need to do multi-hop analysis with the time dimension. So this type of analysis can be done with MPP database, graph database like TigerGraph. All right, any other questions? Okay, I think we're good with the questions. I want to mention here that there's a new Graph Guru Developer Office Hour that we're starting on March 7th at 11 a.m. Pacific. And in this session, you can speak directly with our core developers every week, and you can get any answers to the questions related to GSQL, as well as how to do system management for TigerGraph. And the information is here. You can find more about office hours through the link. And you can also watch previous episodes and more planned Graph Guru episodes from the other link at the bottom. Some additional resources, you can find more information on our developer portal, and you can develop the Developer Edition and Guru scripts. Our recording and Guru scripts will be on the GitHub, and you can join our developer forum. Thank you everyone for joining us today. Bye.